Okay, so today we are talking about pedigrees. And pedigrees are very similar to something that you've probably heard of before, which is family trees. So this here is a picture of the family tree of Queen Elizabeth of England, her children, and then their children, and so on. So I'm going to use this kind of like a guide to what we're going to talk about today because it's very similar. So Queen Elizabeth is the first generation that we're talking about, and she had 4 children: Charles, Anne, Andrew, and Edward. See, it's connected by these lines. And then their wives, so Princess Diana was Charles' first wife. She passed away, and he remarried. And then we have the same thing over here. Princess Anne, her first marriage, and her second, and then from them is all of their children. And so in the news right now, there's a lot of talk about Prince Harry and how he left the throne. So let me show you how he would have taken the throne had he had the chance. And so right now, Queen Elizabeth, her firstborn son, so it goes in progression. We got firstborn, secondborn, thirdborn, fourthborn. The firstborn son is Prince Charles, and he is the first in line to the throne. And then his son, him and Princess Diana's son, Prince William, is the second in line to the throne. And then it goes to his kids, third in line, fourth in line, fifth in line. And then it comes back up to Prince Charles' second-born son, which is Harry. So he's 6th in line to the throne. His kids would have been 7th, 8th, and 9th in line. But because him and Princess Meghan decided to leave the lineage, they no longer have any claim to the throne. So then it moves past them up to the next family, which would be Princess Anne and her family. Okay, so I just want to show you that it's really connected. Family trees, I'm sure if your families have ever been interested in Ancestry.com or DNA tests, which is really big right now, a lot of people like to know where they came from. This is how we organize our family history. So we're going to do something very similar to that today. We are going to be in our notebooks on page 74. This is our last thing that we're going to discuss before we move on to our next unit. Page 74, we are going to title that Pedigree Charts. So if we need to pause the video, pause it here to allow everybody to get their notebooks so that they can get a piece of, or turn to page 74. We're going to turn it sideways. And we're going to title this, make sure we can all see it, Pedigree Charts. So pedigree charts are like family trees, but we are a little bit more official with this, and we don't show pictures. Instead, we show shapes. And so we're going to write the definition down first. A pedigree chart, let's go ahead and write it as I write it. Pedigree shows the relationship make sure that's visible, within a family. So it shows relationships, but why we learned about this in this unit is because we've been talking about genetics. This tells us and allows us to trace, to track or trace a genetic trait or disorder. And so before this, you watched this video, you were shown a video about pedigree charts. It tracked the recessive trait of blonde hair. So we're going to talk today about an unknown trait to start with, so you don't know if it's dominant or recessive. But we're going to start with a little bit of a key. So in every pedigree that you have, there will be a key. This key, so draw this with yours, says that squares are males, circles are females. And that's always the case. We represent males with boxes or squares and females with circles. And if two are married, we represent that with a line between them. So this shows a marriage. So we're going to start with a generation. We're going to have a woman and a man. They fall in love, they get married, and they decide to have children. The way that we show children is a line perpendicular to the marriage line. And we start with the firstborn child farthest left and then we go from left to right with H. So they had a son first. A son is drawn with a square. Then they had a daughter. They had one of each. They thought they would stop there, but then they decided to have another child, and they had a second daughter. So male, female, female. And we represent, or we show, the generations with Roman numerals off to the side. So this is generation 1. We've now drawn generation 2. Okay, so follow me as we go through this. This male, this firstborn son, married and had 2 children of his own. He had 2 sons. Their second-born daughter never married, never had children, but their youngest daughter did. She married and had a daughter. And so we need to add our third generation here. Hopefully yours looks better than mine. We got a third generation. So we could say how they're related. These are the children of our first generation. So what does that make their relationship? Generation 1 and generation 3. Generation 1 is the grandparents of generation 3. So we got grandparents, parents, children. Now these two, how would they be related? We got one son and one daughter that had children. These would be cousins. So in some of the problems that we'll work today, it'll ask how it's related, how they're related. And we start with the generation, and then we can number the individuals either from each generation, so generation or 1 and 2. We can continue numbering 3, 4, 5, 6, 7, 8, 9, 10. Sometimes you'll see that. Sometimes they'll say generation 1, number 1, generation 1, number 2, generation 2. And since today's worksheet works like this, I'll use where we renumber each row. Sometimes you see it both ways. Each row is renumbered starting with 1. Sometimes you see it where it starts at the top and continues on to the bottom. Okay, so now we're going to track. This says you can track genetic traits or disorders. We're going to track a disorder. The grandparents, the first generation, didn't have the disorder, but their firstborn son did. Their daughters did not, but the man that married the youngest daughter had the disorder, and their child had the disorder. And the cousin of generation 3, number 3, also had the disorder. So whenever you're given a pedigree on a test or on a worksheet, it's usually already filled out for you. You may have to label the generations. You may have to label the people, the individuals. But this is how we'll start. Okay, so we're going to track this disorder, and the first thing is to figure out, is this disorder dominant or is it recessive? The way that we can do that is we can look at the individuals who are shaded, or the ones that have the disorder, and we can see where they came from. So in order for this firstborn son to show up with the disorder and the parents not have it, then this trait must have been hidden in this generation. And so with that being said, a hidden trait is a recessive disorder. So we're going to write that at the bottom. This is recessive. And because it's a recessive trait, we now can label. Let's use the letter A. And since the recessive trait is our disorder, we're going to say that this is the family tree for albinism. So little a is albino, big A is normal pigment. And we've used albino a lot, so we're going to continue on with that. We can track it in this family tree. Okay, so in order for them to be shaded, they must be homozygous recessive because it's a recessive trait. So that means this individual, we can label their genotype as a little a. This individual could be a little a, as well as this one and this one. So that's the easy part. We know that they had to be homozygous recessive in order for them to show up with the trait. But now let's go backwards to generation 1. In order for them to have a child with little a, they both had to have a little a. I'm going to say that again. In order for this child to be little a, his parents, had to both carry the trait. But they don't show up with the trait. They show up as normal pigment. So that means that their other letter is a big A. So they are carriers for the disorder. Remember, carrier means that they carry it, but they do not show up with it. And now in order for this family, this man and woman to have a child with little a, individual 1 had to also be heterozygous. Okay, which then brings us over to the last couple over here. In order for them to have a child with little a, individual number 4 had to be big A, little a as well, because he had to give the little a as well as number 5 giving the little a. But he shows up as normal. So let me go down, or we can look at this individual here. Well, we have no extra information to figure out. Is this person a carrier, or is this person homozygous dominant? We don't know. They could have gotten a big A and a big A from both parents, or one of each from each parent. So we will write it as either or. Sometimes you just don't have enough information. So we write them down with both. So we have one more individual to identify. This individual had to get a little a from their dad. They show up as normal, so they have to get a big A from their mom. And that is mapping this pedigree, or labeling this pedigree with the genotypes. So let me go over that all, summarize that all over again. You have a male married to a female. This is the marriage line. They have 3 children. The marriages are attached to them, and then they have children below. We have 3 generations shown here. Pedigrees can get very complicated, and you can show many generations. When I return, I'll show you a pedigree on King Henry in his complicated, or Queen Victoria in her complicated pedigree of hemophilia. Okay, so let's do one more example. So that's page 74. Turn to your next page, page 75. And so we can write pedigree charts again. Okay, so this pedigree chart, we're going to start with 2 couples. We have a man and a woman who both have the disorder that we are tracking or tracing. Okay, we have another couple who are married, and one has the disorder. We'll get back to relationships a little bit later on, but we're going to go ahead and label this generation number 1. So there's no connection here. We just have 2 families that are off in the world, living their life. They meet and they get married. Well, the first couple has children. They have 3 children. Their firstborn is a son. Their secondborn is a daughter, and their thirdborn is a son. Their first 2 children have the disorder. Now this couple has 2 children. They have a daughter and a son. The son has the disorder. So again, 2 families. Now we have a generation 2. They both had children of their own. They're living their life. And this woman and this man meet, fall in love. This connects the 2 families. They now have 3 children of their own. And none of them have the disorder. Okay? So our job is to figure out, is this a dominant or is this a recessive disorder? Let's make our key off to the side. We have shaded, affected male. A shaded circle is an affected female. Okay? And so now let's start, I'm going to write my 3rd generation. Let's start with this first family here. We have 2 individuals, a man and woman, who both have a disorder. And then they have children, 2 with the disorder and 1 without. So I like to start with seeing if it could possibly be recessive. If it is a recessive trait, meaning that these two here both show homozygous recessive, then that means that the only version of the trait that they have, and do not write this, I'm going to write it in pencil so I can erase it just to check. Let's use the letter H. Let's say that H is, think of a dominant disorder. Say, mine's going blank, I can't think of one. Let's just do something simple. Let's not say disorder, let's just do a characteristic. Let's say black hair. And the little h is going to be blonde hair. Something simple. We can track either disorders or characteristics or traits. We're going to track the hair color trait for black and blonde. And so if these individuals are blonde hair, saying that this is the recessive trait, then that means that all of their offspring would only have the opportunity to get the little h. And so that means that all of their offspring should have the little h. And is that what we see? It is not. We have one individual that does not have the little h's. So that can't be it. It cannot be recessive, which means it has to be dominant. And so if it is the dominant trait, we could either have big H, or big H, little h. We got big H, or big H, little h. So we can figure this out. That means that all of the ones that are shaded must be the dominant trait. So the ones that are not shaded are the recessive trait. So then we can track, or we can mark all of the ones that are not shaded now as homozygous recessive. Because the only way that they cannot be shaded is if they have no dominant traits, which in this case would be the big H. And so now, since this individual has two little h's, their parents had to have the little h as well. So this has a little h and this has a little h, which means we can then erase the two big h's. The parents must be, make that look a little bit better. You can now write this. These parents are heterozygous. I'll write these in pen. They're permanent. So now that we have a majority of them labeled, we can go back and label the rest. Okay, so these two individuals, they show up with the disorder, so they must have at least one big H. And now they could have gotten the big H from this parent and the big H from this parent, or big H from either parent and a little h from either parent. So we can't narrow it down to any further than that for both of these individuals. Now, if we had more lineage from these two, we might be able to figure it out, but right now we don't. Okay, and so let's go back up here. They have this family had an individual with little h, so that tells us that this dad had to, we know it has the big H because it's shaded, had to have a little h in order to donate that little h to his daughter. So this is how you can hide traits. Recessive traits like blonde hair or colored eyes, whenever both parents have brown eyes or dark hair, and then they have a child with light eyes or light hair, in this case black hair with blonde hair child. You can hide that recessive trait, which we found that out in monohybrid crosses, but this really shows it. You can see how generations can hide traits, or it can skip generations. Okay, and so this parent had to donate the little h. This parent must have donated the big H because it is shaded, and we are done. Okay, so we figured out this one was a dominant trait. So now in your notes, you have an example of the recessive disorder on page 74, and you have an example of the dominant disorder on 75. So when you walked in today, or whenever you were handed your worksheet, you have a worksheet that looks like this. Okay, this looks like a lot of questions, but really what it is asking you step by step to analyze this pedigree. And there are quite a few pedigrees in here. You got 1, 2, 3, 4, 5, 6 pedigrees. So I'll do the first one with you. Make sure that you understand it. So let me zoom in for you. All right. So in this pedigree, a square represents a male, and if it is darkened, it is hemophilia. If clear, he had normal blood clotting. So that means that all of the ones that are darkened here has hemophilia. So this one just asks how many males are there? And remember, males are squares, females are circles. So we have 1 male, 2, 3, 4, 5, 6, 7, 8 males. And how many have the disorder? And it says that if they're shaded, they have the disorder. So we have 1, 2, 3 with the disorder. So pretty simple to start. It's just asking you to label or to figure out males and females. We'll label it in just a minute. A circle represents a female. If it is darkened, she has hemophilia. If it's open, she is normal. So let's answer this one. How many females are there? 1, 2, 3, 4, 5, 6, 7, 8 females. And if she has hemophilia, it's shaded. So we got 1, 2 with the disorder. A marriage indicated by a horizontal line connecting the circle to a square. So one marriage, a marriage here, a marriage here. How many marriages are there? We just counted that there are 3. A line perpendicular to a marriage line indicates the offspring. If the line ends with a circle or a square, the couple had only 1 child. However, if there is a connected to another horizontal line, then several children were produced. Each indicated by a short vertical line connected to the horizontal line. So that shows it here. Marriage with 3 children, a marriage with 1, 2, 3, 4, 5, 6, 7 children. It's a lot of kids. The firstborn child appears to the left, and it progresses from there. So the oldest, the youngest. It says, how many children did the first couple have? So in this first row, this couple had 2 children. They did not have this child. This person married into the family. That's what the line represents. How many children did the third couple have? We got the third couple here. 1, 2, third couple here. 1, 2, 3, 4, 5, 6, 7 children. How many generations are there? That's off to the side. We got 1, 2, 3, 4 generations. And how many are in the 4th generation? We have 7. Okay, so that one was identify the pedigrees. We've identified this pedigree here. At the bottom asks you some other similar questions, but then it's going to ask you to write the genotypes of each individual on the pedigree. You're going to do just what we did in the notes, and you're going to label each of the individuals with whatever letter you would like. This is talking about Huntington's disease, so Huntington's disease, I would probably label it with an H. You're going to figure out if it's dominant or recessive, and then go from there. Okay, this is due at the end of class. If you don't finish today, and you are working diligently, then you may take it home. If you choose to not work at all, then the substitute today will pick it up and take the grade that you deserve for working today. Make sure that you're on task. Make sure that you are following all of my expectations. No phones, no headphones. Be respectful to your substitute, and I'll see you when I return.